This is the PCB circuit board we're all familiar with, but do you know how it's made? Let's take a close look at several key processes in PCB manufacturing. First, let's use this simple circuit to understand what a PCB is. Its circuit diagram is drawn like this. You can wire it by hand according to the schematic, or you can use a PCB board to create a more precise integrated circuit. If the circuit is more complex, then this kind of hand-wired circuit starts to look pretty tangled. That's why large-scale integrated circuits must use PCB boards. Before manufacturing a PCB circuit board, the customer's schematics need to be checked and optimized. Then boards with the same properties, such as thickness, number of layers, and color, are grouped together and laid out on a single copper-clad board. This step is called panelization. The most common materials for PCBs are epoxy resin boards and fiberglass boards, both coated with a layer of copper foil on the surface. The first step is to cut them to size. This is a cutting machine, and its function is to cut the copper-clad boards into the appropriate sizes. The cut boards will also have their edges polished as they move along the conveyor line. Smooth and rounded edges can effectively prevent damage to the PCB surface. Next, positioning holes need to be punched at both ends of the board. The purpose of the positioning holes is to provide reference coordinates that the equipment can recognize. You can see that there are very few workers inside. The entire manufacturing area is occupied by highly automated equipment. This time we're visiting several core processes that have attracted a lot of attention. This is the drilling area, where automatic drilling machines change drill bits automatically according to the different types of holes required. The range of drill bit sizes is very comprehensive, with the smallest bit having a diameter of just 0.15 millimeters. The entire drilling process is controlled by computer from start to finish. For via in-pad holes, which currently have a very high manufacturing threshold, not only are these CNC drilling machines required, but laser equipment is also needed to further improve drilling precision. The via in-pad process involves drilling holes directly into the pads, then filling the vias with resin, and finally sealing them with copper electroplating. This process not only makes the routing neater and more aesthetically pleasing, saving board space, but also enhances heat dissipation and conductivity. However, this process places extremely high demands on both the technology and the equipment. This long production line is for electroless copper plating, which involves plating a layer of conductive copper foil onto the walls of the through holes. First, the drilled boards are soaked in a special solution to make the whole walls more receptive to copper ions. This step is called activation. Next, the activated boards are placed into a solution containing copper ions, allowing the copper ions to deposit onto the surface of the whole walls. At this point, the metallic conductive layer on the whole walls is formed. This staff member is preparing for the circuit fabrication process. The first step in creating the circuit pattern is to cover the board with a layer of blue dry film. The dry film is a photosensitive material that is particularly sensitive to ultraviolet light. Next, LDI exposure technology is used to transfer the circuit pattern onto the dry film, and then the board is placed into a developing machine to wash away the unexposed dry film. The electroplating process involves first plating a layer of copper onto the exposed copper foil, followed by a layer of tin, to prevent it from being damaged during the subsequent etching process. After electroplating, the semi-finished PCB is sent into a stripping machine, where the unexposed dry film is dissolved with stripping solution. Then, etching solution is used to remove the exposed copper, while the copper foil covered by tin remains intact. Finally, a tin stripping machine is used to remove the tin from the circuit, leaving behind the desired circuitry. This is a testing device called OLLI, and the young lady is performing an optical scan on the PCB. To ensure product quality, multi-layer boards or PCBs with hole diameters less than 0.3 millimeters must undergo a low-resistance test to prevent defective holes from entering subsequent processes. Lamination refers to using high-temperature and high-pressure equipment to press circuit boards into multi-layer boards. The workers first separate the single-layer PCB boards with insulating layers. During lamination, boards with copper foil are also used as intermediate layers. Then, pre-preg material and copper foil are added and laminated together. Finally, the assembly is sent into the pressing equipment, where it is formed by applying heat and pressure. A layer of solder mask ink needs to be applied to the surface of the PCB board. Then, a special process is used to expose the metal pads, followed by printing white text that represents component information. This step is called silk screen printing. Finally, processes such as outline machining and flying probe testing are carried out. After completing all the above processes, the board needs to be cut, then the shaped PCB boards are cleaned again, and a comprehensive performance inspection is conducted on the boards. Finally, the PCB boards that pass inspection can be packaged and delivered to the customer.